Okay, so the last topic we have to revise is Cc11, which is all about metals and extracting metals. Okay? If you were asked for properties of metals, so characteristics of metals, there are lots of things you can say, but probably the easiest ones to remember are metals are shiny and metals are strong. Okay? You could also say that metals can conduct electricity. You could say that metals have a high melting point. You could say that metals are malleable, which means they can be hammered into shape. But probably the easiest properties to remember are just metals are shiny and metals are strong. Okay? Metals are also reactive. So they do occur naturally in the environment, but because they're reactive, they react with the other elements around them. Every time metals react, they always lose electrons, okay? Every single time. If I look at 3 examples of metals, I've got sodium, which is a group 1 metal, magnesium, a group 2 metal, and aluminium, a group 3 metal. Because sodium's in group 1, it's got 1 electron in its outer shell. Magnesium has 2 because it's in group 2, and aluminium, which is in group 3, has 3 electrons in its outer shell. I've said that when metals react, they always lose electrons. Sodium has 1 electron to lose. Magnesium has 2, aluminium has 3. Okay, so sodium loses 1, magnesium loses 2, and aluminium loses 3. And when they lose their electrons, they form ions. Okay, so when they've got all of their electrons, we call them atoms. When they lose their electrons, we call them ions. And because they're losing electrons, they are forming positive ions. Okay, sodium has lost 1 electron, so forms Na plus 1. Magnesium loses 2, so forms plus 2. Aluminium loses 3, so it's forming plus 3. They always lose electrons, and they always form positive ions. If they lose 1, they're positive 1. If they lose 2, they're positive 2. If they lose 3, they're positive 3. Okay? So I can say that they always form positive ions, all right? So it's important to be able to read what those charges mean, okay? So a different way of phrasing the question will be, how does calcium become Ca2+? I know that that plus means that it's lost electrons, and that 2 is telling me it's lost 2 electrons. So calcium loses 2 electrons to become Ca2+. How does potassium become potassium plus? That plus tells me it's lost an electron, and because it's plus 1, it tells me that potassium has lost 1 electron to become K plus 1. What about iron? Okay, iron is Fe3 plus. Okay, how does it become Fe3 plus? That plus tells me it's lost electrons. The 3 tells me it's lost 3 electrons. Okay, so what we can see here is that metals always lose electrons, and when they do, they form positive ions. If they lose 1, they're positive 1, lose 2, positive 2, lose 3, they are positive 3. Okay? The other thing we need to look at is how you are going to extract metals. Okay, and for this, you need your reactivity series. So what I've got here is a list of metals in order of the reactivity. I've got potassium right up here at the top because it's the most reactive, and I've got gold down at the bottom. So I've told you that metals do occur naturally in the environment, but because they're reactive, because they want to lose their electrons, they react with the other elements around them. Because they react with the other elements around them, you're not going to find pure potassium in the environment. You're not going to find pure calcium in the environment. Instead, you are going to find compounds. You're going to find potassium after it's reacted with oxygen. You're going to find calcium after it's reacted with oxygen. Okay? And extraction techniques are just a way of getting the pure metal back. So if you want potassium back from potassium oxide, you want iron back from the iron oxide, you use these techniques to extract the metal from the compound, to get pure metal back from the compound. And there are 2 main techniques: electrolysis, which we've already looked at, and reduction with carbon. And you can use your reactivity series to see which technique you are going to use. So you'll notice in your reactivity series, I've highlighted carbon in yellow. The reason it's highlighted is because it is a non-metal. but I've included it on my list of metals. Why? Okay, the reason is because I can use carbon to extract metals, but I can only use carbon on the metals that are less reactive. So I can use carbon to get zinc back from zinc oxide. I can use carbon to get iron back from iron oxide. I can use carbon to get copper back from copper oxide. But I cannot use carbon to get calcium back from calcium oxide, or to get potassium back from potassium oxide. So the technique is called reduction with carbon, but I can only use it on the metals less reactive than carbon. That's why it's handy to put carbon into the reactivity series so you can see which metals are less reactive. You'll be given the reactivity series in your exam, but they won't tell you where carbon is. You need to learn that carbon comes after aluminium so that you can put it in yourself, and then you can predict the extraction methods. Every metal more reactive than carbon, you have to use a different technique, and that technique is electrolysis. I'm just going to show you an example of what I mean by reduction with carbon. Okay, so over here I have got zinc oxide. So zinc after it has reacted with oxygen, and I'm reacting this with carbon. What will happen is that carbon will take zinc's place. And when it takes zinc's place, you get carbon dioxide and you've got zinc by itself. So you've got your zinc oxide, you react it with carbon, carbon takes zinc's place, leaving you carbon dioxide and zinc. You end up with pure zinc, the pure metal, which is what you are trying to do. If I do that same reaction with iron oxide, the same thing will happen. Carbon will take iron's place, you get carbon dioxide, and you get iron left by itself. These reactions only work if carbon is more reactive than the metal. It's more reactive than zinc, it's more reactive than iron, so these reactions take place. But if I come down here to magnesium oxide, carbon is less reactive than magnesium. And because it's less reactive, it cannot take magnesium's place, so I get no reaction. Okay, I see that here on my reactivity series, carbon can take the place of zinc, it can take the place of iron, but it cannot take the place of magnesium. And if you were asked why does this reaction not take place, you would say carbon is less reactive than magnesium, so carbon cannot displace magnesium. And by displace, I just mean take magnesium's place. Carbon is less reactive than magnesium, so carbon cannot displace magnesium. Because carbon cannot displace magnesium, if I wanted to get the magnesium back from the magnesium oxide, I would need a different technique. I would need, magnesium's here, electrolysis. Okay? I'm calling this technique reduction with carbon. You need to know what reduction means. Reduction means you are removing oxygen. So you need to look at your equations and see what is losing oxygen. What has oxygen on the left-hand side that does not have oxygen on the right-hand side? Okay, I can see on the left that zinc is with the oxygen. It's zinc oxide. Zinc and oxygen are bonded together. But on the right-hand side, zinc is by itself. Zinc oxide is being reduced. Okay, so reduction is the removal of oxygen. Zinc oxide is being reduced. It's losing its oxygen. And on the right-hand side, it's just zinc. In the next equation, iron oxide is being reduced. It's got oxygen on the left, iron oxide, but there's no oxygen with iron on the right. So iron oxide is being reduced. The next one, copper oxide, is being reduced. Copper is with oxygen on the left-hand side, but on the right-hand side, there is no oxygen with copper. Copper oxide loses oxygen, so I can say copper oxide is reduced. That's why it's called reduction with carbon, because the metals get reduced because of the carbon. Okay, so the name of the technique is reduction with carbon. They lose carbon because, they lose oxygen because of the presence of carbon. The other two techniques that I mentioned here, phyto extraction and bioleaching, They are called the biological techniques. Okay, and the way they work, phyto extraction, you will grow plants, okay, and the plant's roots will stretch down into the soil. And in this soil, you have got metal ions. So just say, for example, you've got copper ions. And what will happen is the plant's roots will absorb the metal ions. So all of the metal ions that are floating around in the soil, they will be absorbed by the plant. And all of those ions will go into the roots of the plant. So I'm going to say plants absorb the metal ions. And I have to write metal ions. They don't absorb big solid chunks of metal. They can absorb metal ions. So plants absorb metal ions. And then the plants are burned. You light them on fire, you burn them. Plants are burned and the metal ions are extracted. So you plant these plants on soil that you know has lots of metal ions. All of those metal ions are absorbed into the roots of the plants. So plants absorb metal ions. And once you've got lots of ions in the roots, you will pull up the plant, you will burn it, and then you will be able to get the ions from the ash of the plant. Okay, so it's called phyto extraction, and that's how it works. The other biological technique is called bioleaching. And in bioleaching, you use bacteria, which is obviously a living thing. That's why we call them biological techniques. And you use bacteria to break down ores and turn ores into a solution. So ores are the rocks that contain metals. You have a special type of bacteria that can break down these ores, break down these rocks, and turn these ores into a solution. And once you've got the metal ions in solution, you're able to get the metal ions out. Okay, so they're the two different biological techniques. All right. All of these extraction techniques have kind of advantages and disadvantages, but if I look at all of them, reduction with carbon, if we look at this technique first, you can see reduction with carbon. You're producing carbon dioxide every single time. Carbon dioxide is not good for the environment, okay? It causes global warming. With electrolysis, you need electricity, okay? And you need large amounts of electricity, which costs lots of money to generate, okay? With your phyto extraction, your bioleaching, okay? These processes are really slow. And bioleaching in particular releases lots of toxic gases to the environment. So all of these extraction techniques, they cost money. They're not particularly good for the environment. Okay, so another alternative is just recycling. Recycling the metal that we already have instead of always trying to get new metals. What about recycling the metals we already have? And we're just going to look at some advantages. Advantages of recycling. Okay, so I'm going to say one advantage of recycling. Okay, so if I recycle, okay, I don't need to do reduction with carbon. So I'm going to say an advantage is if I'm using reduction with carbon, it produces lots of CO2. And CO2 causes global warming. Okay, if I'm recycling, I don't need to use reduction with carbon, so I'm not producing lots of CO2, which is causing global warming. I'm going to say electrolysis uses lots of electricity. Okay, that's expensive. And also, the generation, if you're generating electricity, that's also producing CO2. So an advantage of recycling is you don't need to use reduction with carbon, so you're not producing as much CO2. An advantage of recycling is you don't need to use electrolysis, So you don't need to use lots and lots of electricity, which is expensive and also produces CO2. Okay. Other advantages of recycling is that it reduces landfill waste. You're not sending as much waste to landfill, so it reduces landfill waste. And the other thing is, in order to do these techniques, reduction with carbon and electrolysis, you need ores. And you get ores by digging down into the ground. Okay? Mining is dangerous. That's what it's called, digging down into the ground. That's mining. Mining is dangerous. And mining also is unsightly. Okay? So if you have to dig a big mine in a countryside, you're digging massive holes, it doesn't look very nice. It ruins the landscape. So I'm going to say reduces the need to mine. I'm going to write mining is dangerous and it damages the landscape. Okay, so advantages of recycling, of reusing the metals we already have. If you're recycling metals, then you don't need to use this extraction technique, so you're not producing lots of CO2. If you're recycling the metals you already have, then you don't need to use electrolysis either. So you don't need to make lots of electricity, which also produces CO2 and is very expensive. If you're recycling the metals you already have, then you're putting less metals into landfill waste. If you're recycling the metals you already have, then you don't need to go mining or digging for more metals. And mining is dangerous and it damages landscapes. We want to avoid mining where possible. Okay, so when we're talking about metals, all right, they do occur naturally. You can extract them using these techniques, but it's also good to recycle the metals that we do have instead of constantly trying to extract more. There are questions that you can complete on this topic in your revision guide, in your core info guide. So metals is here on page 25, okay? I go through the kind of key questions, I give you the answers, and then I give you some practice questions to do, okay? So I wouldn't advise you to do all of the practice questions. I would advise you, oh, my pen's run out. I would advise you to do question 2, question 3, question 4, question 7, question 10, 11, and 12, and 13. 2, 3, 4, 7, 10, 11, 12, 13. Okay, so 2, 3, 4, 7, 10, 11, 12, and 13. The answers to all of those questions are below, but instead of just looking at the answers, do the questions by yourself. Once you finish the questions, go back and mark them.